This is going to be the last section of chapter 9, and this is going to be quadratic inequalities. So first, let me tell you what a quadratic inequality is. So a quadratic inequality, so let me just write this like this, is an inequality that contains a quadratic expression. Okay, so that's basically all it is. So usually you will encounter something that looks like this: ax squared plus bx plus c greater than or equal to 0, or you might get ax squared plus bx plus c less than 0, something around those lines. So if you think about it, if you look at these problems, basically what am I asking you? Well, here is the parabola. If I'm asking you the first thing, I'm saying, where is this parabola greater than 0? So when I say greater than 0, well, what are numbers that are greater than 0? Well, all the numbers that are greater than 0 are positive. So basically what I'm saying is, where are all the values that are positive? And if you can see, the values that are positive are here and here. Right? Those are the values that are positive. Now, if you look at the bottom portion, this is all, where is this parabola less than 0? All the numbers that are less than 0 are negative. So what I'm saying is, where is the parabola negative? And that's going to be all of this. Okay? Now, if you look at the green one, though, the green one has an equal sign. That means that I'm including where it can be 0. So I'm including the 0. Whereas in the purple one, I'm not including it. So how would you solve problems that look like this? Well, these are very simple to actually do. They just look really scary. So to solve quadratic inequalities, I'll just write them as QIs. The first thing that you want to do is write the inequality, write the quadratic inequality in standard form. And what I mean by that is that I want it as ax squared plus bx plus c is less than 0 or greater than 0, whatever you want to call it. The second part is that you want to solve as if it was an equation. Just like if it was an equation, so set it equal to each other. Okay. Third, plot points in between intervals to determine positive or negative. And then just write in interval notation. So hopefully you did not forget about interval notation. Okay. So right after you solve these or wrote all of this down, we'll start doing some problems. So here is my first example. So solve and write in interval notation. So I'm going to solve and write it in interval notation. So I'm going to have x squared plus 2x minus h is greater than or equal to 0. All right. So the first thing that I want to do is I want to check if it's in standard form, and it is. I have it in the form that I want to. I have the 0 on the other side, and I have the quadratic equation on the other. Okay. Now, if you look at here, look at all this greater than sign, we have an equal sign. So that means wherever it's 0, it's included. We're including wherever it's 0. Not only that, it's greater than. That means I'm looking for positive values. So I'm looking for two different things, including the 0, and I'm only looking for positive values. Okay, so now number 2 says solve if it was an equation. So I'm going to write this as x squared plus 2x minus 8 equals 0. So I'm going to solve it as if it was just this. Well, I can use quadratic formula. Actually, what would be easier is just to factor it. So this will be a 4, this will be a 2, this will be a plus, and this should be a minus. Okay, so my answers are going to be x is equal to minus 4, and x is equal to 2. All right, so here are my two values. Okay, so what I'm going to do is I'm going to make a number line. Something that looks like this. Here is negative 4, and here is positive 2. Now, are these numbers included or not included? Well, they're included, right? Because we had an equal sign. So these points are included. So I'm including these two things. And now what I'm going to do, I'm going to start testing. So I'm going to start testing every interval. So I'm going to test this interval, and this interval to see where it is positive. Because remember, I'm looking for the positive values. Okay? So the first thing I'm going to do is I'm going to plug in, whoops, what happened? I'm going to plug in a value that's less than negative 4. So a number that is less than negative 4 is going to be negative 5. X equals negative 5. So I'm going to put that into the quadratic equation. Negative 5. So whoops, let me write it like this. So x squared plus 2x minus 8 is greater than or equal to 0. I'm going to plug in the negative 5 squared. Negative 5 minus 8 greater than or equal to 0. We want to make sure that this is true, that it is positive. I'm going to get 25 minus 10 minus 8. Is that greater than or equal to 0? Well, this is just going to give me 15 minus 8. Oops, oh, I don't know why I wrote 10. Which indeed is greater than 0. So anything over here is okay. So this is okay. We're good. This is a good thing. Now, what about anything in the middle? Well, let's choose a number that's between negative 4 and 2. Well, a number that's between negative 4 and 2 would probably be 0. So 0 is a good candidate. So let's see. I have x squared plus 2x minus 8 greater than or equal to 0. I'm going to plug in 0. 0 squared plus 2 times 0 minus 8 greater than 0. Oh, we got a negative 8. Remember, we only wanted positive values. This is a contradiction. This is not correct. So there's no solution in there. All right, and now the last thing that we're going to do is check over here. Number that's greater than 2. Well, in this case, a number that's greater than 2 is x equals 3. So I'm going to plug in 3 into my solution, to my quadratic inequality. So 3 squared plus 2 times 3 minus 8. Is this greater than or equal to 0? Well, I have 9 plus 6 minus 8, which is definitely greater than 0. So all of these are also solutions. Okay? So now all I got to do, now that I've plot points in between the intervals to determine positive or negatives, all I got to do is now shade where everything was good. So this was from negative infinity. So from negative infinity all the way to negative 4. Negative 4 was included. Union, nothing in between, 2 all the way to infinity. So this is my answer. Here's my solution to this quadratic inequality. Okay, a little bit of a lengthy process, but still you are able to do it. Okay. All right, so now let's try this other problem. So that was part A. Let's do part B. Part B. X squared plus 8x is less than negative 12. Okay, so this is the problem that we're going to do. So the first thing is that we need to figure out whether this is in standard form. And it is not in standard form because we want it in like this. So we want a 0 on the other side. So we're going to add the 12 first. So we're going to have x squared plus 8x plus 12 is less than 0. Now notice a couple things. A, we are not including values where it equals 0 as before. Because in the other one we had an equal sign. This one we don't, so we're not including it. So you're going to have an open circle. And another thing is that now we want negative values because it's less than. So we're only looking at the negative values. All right, so now the first thing that we want to do is solve this problem just like we would a regular inequality. A regular equation. So we're going to have x squared plus 8x plus 12 equals 0. And now let's solve this. So this is just going to be x and x, and then 4 and 2. Oops, that's wrong. 6 and 2, because 6 times 2 gives me 12. 6 plus 2 gives me 8. They're both going to be positive. So x equals negative 6 and x equals negative 2 are going to be my solutions when I set them equal to 0. So now I'm going to do a number line. Here is negative 6. Here is negative 2. Because I know that they are not included, I'm going to write an open circle for both of these. And now all I have to do is just plug in numbers. So first let's look over here at x equals negative 7. I could choose any number that I want. So right now I have x squared plus 8x plus 12 has to be less than 0. I'm going to plug in negative 7 here. 8 times negative 7 plus 12 less than 0. This is I'm going to get a positive 49 minus a 56 plus a 12 less than 0. This actually is not going to be less than 0. So there is nothing there. Okay, everything there is not correct. Okay, so before it was, now it isn't. Okay, because this is a contradiction. If you put this in the calculator, this is a positive number. Positive number is not less than 0. Okay, now let's choose a number that's in between these two numbers. So for example, x equals negative 3. So I'm going to have x squared plus 8x plus 12 is less than 0. I'm going to plug in negative 3 plus 12 is less than 0. So 9 minus 24 plus 12 is less than 0. Clearly, this is going to be a negative number. So everything here will be a solution. So this is okay. We got negative values. That is correct. And now finally, we just got to check the other side. So I'm going to make this color. So on this side, we can just choose x equals 0. Because 0 is less than negative 2. So we have x squared plus 8x plus 12 is less than 0. Plug in 0 here. 0 squared plus 8 times 0 plus 12. Clearly, 12 is not less than 0. So there's nothing here. So my solution set is only going to be between negative 6 all the way to negative 2. And none of these are included. This is going to be my solution. And that's all there really is to quadratic inequalities.